Hey guys, welcome back to Embedded System Programming with the STM32 microcontroller. In this tutorial, we're going to look at how to configure the serial communication with this Nucleo 64 board. Now, this board have a functionality to create a virtual serial port. Now, using that virtual serial port, we can basically write information into the ST and then send it onto our computer, because as it is already connected with a USB like this, it will create a USB virtual serial port that we can detect on our computer and then send data from the chip into the computer. So we're only going to use a transmit functionality. Now, as you can see, we have almost a blank project with only the previous code we have written. Now we're going to configure our serial communication with the HAL library, the HAL library. Now, in order for us to make good use of the HAL libraries, we have to call the initialization, the main initialization function of the HAL library, which is HAL_init. Now, in this function, if I may just go in there, in this function, now this function will be responsible for initializing a number of things here, and one of which is the STM32. So that is a system clock timer, and also it will also enable the low level hardware initialization, which is usually, or which is also done into the HAL_MSP init function. So that means we also will have to call this function. Now, because we are now calling this function here, and we do not have a source file here for the MSP, right, onto our source code here, because we are working from a skeleton project. So we basically will have to add a new source code here where we're going to reference these MSP init functions. That is the low level hardware initialization function. So the bottom line is this HAL init function will ensure that if you are using interrupt, they're going to work because your system clock is enabled. And if you are enabling other peripheral clocks that are based on timers and other things, they are also going to work correctly because you are initializing them inside this function. Unless you're going to create your own function that's going to do all these other initializations of the system clock. But if you are using the HL library, make sure that you have this file called first. Right. Another important factor to note is that after calling this function and it goes into the initialization of the STM32 timer, now this STM32 timer is then configured to generate an interrupt every 1 millisecond. So what we have then now to do is we must create another file into our source file here, and that will be the interrupt source code. So that interrupt source file must have a function that is going to handle the interrupt. So that is the interrupt service routine, interrupt handle. So let's come in here and create another source file. We're going to call it interrupt.c. Now in this file here, interrupt.c, we have to then create a function that is going to be responsible of dealing with that interrupt that is generated every 1 millisecond by the STM32 timer. So we'll come back into this function and we're going to say void STM32 handler. So that will be the interrupt handler function, and inside this function we're going to call that HL library function that is responsible for handling that interrupt. So that will be STM32. Just like that. Now if we go into this function right here, you can see here is the implementation. So the implementation is that in the default implementation, this variable is incremented each 1 millisecond in the STM32 interrupt service routine. So we're just going to leave this in here so that, okay, whenever we're going to make use of that interrupt that is being generated, let's say we want to call a delay function, a built-in delay of, let's say, 1 millisecond or 1000 millisecond, and that delay function is going to be calling some variable that are generated in this function, which is a SysTick timer, and that SysTick timer then is generating an interrupt every 1 millisecond, and that is then executed with this function here. And here we just need to include header file that is main.h. Now we can go back into our main function. Now we know that whenever we want to call a function that is going to make use of the SysTick timer, we know that we're going to be handling the interrupt that the SysTick timer is going to be generating every 1 millisecond. Now, before we begin writing the initialization setting for this serial interface program, we're going to create another source file here that we're going to call msp.c. The reason for that is that using the HAL library, now if you come to this IOC interface and you generate the code here, it is going to create the msp.c file. The reason it creates that, it generates a skeleton program for you with some initializations settings in there. That is because in the msp.c source file, you're going to find all the low-level hardware initialization, which the serial communication is one of the low-level hardware. So in order to keep things uniform, we're going to have to follow the same protocol and procedures. So I'm going to just come over here and create a new source file, and I'm going to call it msp.c. Now in this source file, we're going to place the MSP initialization function, where we're going to enable a few settings. Now that is normally there when you generate the code using the IOC interface. Just as we did with the interrupt here, I'm just going to copy the main.h source file, because the reason being, inside that main.h, we've got this header file here that we want to access. So I'm going to just paste this here, and I'm going to create my function. So that will be void HAL underscore MSP init, right? And inside this function, I'm going to just initialize a few things that are normally initialized. So double underscore HAL, control space bar. Now we can see the option that we have there. I want to initialize the RCC underscore sysconfig. So I need to enable the system configuration clock for the RCC register, right? And then I'm going to enable another interface that's going to be HAL underscore RCC PWR, control space, and that is going to be the clock that we need to enable as well. So that's a RCC clock we also need to enable there. Now for now, we're just going to leave this like that, because normally, as I say, you're going to find some initialization things enabled here when you generate the IOC code. So since we are now working on a low-level hardware, we have to do this compared to when we were just busy working with simple GPIOs hardware. All right, now let's go into our main function now. Now, in order to configure our STM32 serial communication, we need to write some parameters. So they are low-level and high-level parameters. Now, an example of a high-level parameters is if you come to your device manager here, right? And you go on properties on one of the serial communication port COM1, and you check here, go on port settings. You're going to see all the settings for a particular serial port. These are the bit per second or baud rate, data bits, parity, and all these other parameters. So these are the high level parameter that you have to write. Now this one, we're going to just write them in the main function here on our main file. But now in the MSP here, we're going to put the low level parameters or settings. Now this will be to find the pins that are supposed to be configured for our serial communication here. Now if I may go back into this IOC interface, right? And you're going to realize that here we got the USART TX transmission and the USART underscore RX, which is for receive, right? So transmit and receive. Now transmit is on PA2 and receive is on PA3. Now these two pins here must be configured and initialized in a low level. So these are the settings or the piece of code that we're going to write in the MSP.c file right here, source code. So we're going to create a function here where we're going to write or initialize our GPIO PA2 and write all the other parameters required for the serial port to function onto those two pins. And when we are done there, we can then come into the main function and write all the serial high level parameters that we just saw on the device manager serial port settings. Right, now let's go back into the MSP and write our function. This is an initialization function that is going to access the UART structure that is defined into this header file here. If we may just come down here, we're going to find this guy here, the UART underscore handle type def. So that's the one. So we're going to write the initialization function that is called void HAL underscore UART underscore MSP init. Now inside this function, we're going to pass this parameter here, the UART handle type define. So this parameter is going to give us access as a pointer to these structures here that are defining all the UART serial communication interface. So I'm going to just go back in there and then paste it. And we're going to pass the pointer parameter, which is UART parameter, like that. All right. Now inside this function, we're going to have some low level parameters initialization. Not only that, we are initializing the UART interface, we are also going to be initializing the GPIO settings, because we know that our serial communication on this particular board must be connected to PA2 and PA3, which are the TX and RX pins. So which means we need to initialize the GPIO port as well. Now, just as we were doing here on to the GPIO initialization for this LED that is still blinking here, so we need to access this same init type def parameter. So what I'm going to do here is I'm going to just copy this. Actually, I'm going to cut it out, right? I'll cut it out and I'm going to basically, let me just place it here, right? So this is just a variable definitions. So what I'm going to do now from here is I'm going to access it from the MSP file. So in order to do that, I'm gonna just copy it again, and what I'm going to now do is I will come just up here, just write a comment and say external variable, and I'm gonna paste it here. Now in C programming, you can access a variable that is declared in another file. Like we can see here, it's declared into the source, the main.c file. We want to access it into the MSP .c, so we just have to pass the keyword extern. So when we pass the keyword extern, then we can just have GPIO init type def, and we can have GPIO a init like that. Now if we don't do that, if we don't pass the extern, it's going to clash with this main declaration here. Now by passing the extend, then we avoid that clash. Now we can just access this GPIO a init and pass the parameters for our serial port. All right. Now before we do that, we first need to enable the clock for the serial communication. So that will be underscore underscore HAL underscore RCC UART2 control space bar, and we need to enable the clock. Now we can then go ahead and access now this GPIO a initialization variable that is coming from this structure here we saw in our program when we were writing the binary counter. Now we can say GPIO a underscore ini dot now we can access the pin in which our serial communication will be connected. So we know that it's PA2 and PA3. That must be interface. So we're just going to say GPIO underscore pin underscore 2 or GPIO pin underscore 3. So now we know that this is going to be PA2 and PA3 that we are going to be using. Now the next thing is we have to say GPIO init again, and this time around we're now going to choose the mode. Now just as we were selecting the mode, either input or output, now these two pins are now going to be used for another function. So that's going to be an alternate function. So that's going to be GPIO underscore mode underscore AF for alternate function, and it's going to be push pull. Right, now the next thing we're going to now also initialize GPIO init dot. Now we're now going to access the speed functionality into that structure. Now the speed, we're now going to just say, okay, this is going to be for the high frequency. So it's going to be GPIO because we are going to be doing a serial communication with a baud rate, let's say, of 9600. That's a high speed. So we have to say GPIO underscore speed frec high, like that. So this is a high frequency speed we are selecting for this GPIO configuration. Now the next thing we can paste again GPIO init dot. Now we're going to access another functionality. This one is going to be the pull mode, right? So here we're basically just going to say it's no pull. The reason why it's no pull is because it's going to be an output, because we'll be sending data out, so which means on that alternate function, so we don't have to enable a pull down or a pull high. So we're just going to say GPIO no pull, GPIO no pull. Right, one last parameter in this configuration for this serial port low level configuration, we're going to paste again GPIO a init dot. Now this time around we're now going to select the alternate. So that is the first option there. Now what is the alternate? Now this is the alternate function we want to use for this pin. Again, we already said that the mode is going to be an alternate mode. It's neither input nor output. So it's alternate functionality, push pull. Now we need to specify that alternate mode in which we want to use this GPIO, these two pins here. Now in order to see exactly what are the alternate function for this the serial port, we have to go back into the reference manual, or let's rather check the data sheet. So if I may just open the data sheet of this micro here, okay, and then let's just search for list of table. So if I hit list of tables, okay, then we come here and then we need to find the alternate function table, which is table 14. So we click on there, and when we come into the alternate function table, we can see that PA2 and PA3 are right here on top. And basically in this table, you can actually see each and every pins on your board, what other function you can use them. Like you can see these PA2 and PA3, not only you can configure them for TX and RX for USART 2. Here we can see it's AF7, which is the alternate function 7, but they can also be used for timers. As you can see, yes, timer 2 and timer 2 on channel 3 and 4. And you can also configure them to have an oscillator connected to them. So these are where you're going to see what you have available on your pins. So we can see that we need AF7 as the alternate function. So we're going to then write here GPIO underscore AF7 underscore it's USART 2. So that is the alternate function mode. Now the other place where you can find the alternate function definition, apart from going into the data sheet, is to check the header file here. That is the GPIO underscore x.h. So you click in there, and when you come into this file, just look at your particular board And mindful of reading all the alternate function definitions, you can see here we are looking for the USART2 alternate functions. And if you pay attention, you're going to see USART2 alternate function mapping is here for GPIO F7 USART2. So that is for our board. So this is where you can also find it as per the HAL libraries. Now the last thing now here is just to call the GPIO initialization function, where we're going to pass those parameters. So that is this function. So I'm going to just copy it to avoid writing more code, and then I'll just paste it in here. So I think we are done here on this MSP.c source code. So we can basically just close the file and save it. Now we can go back into the main function so that we can now start writing the high level initialization. Now the high level initialization setting, we already saw that it is where you define your baud rate and your parity bits and all the port settings so that your serial port can work properly. And then we're going to now write the function into the main function, where we can actually start transmitting the data into the serial port using the ST virtual serial port. Right now, as you can see here, I'm still having a code here, but now I'm going to leave this configuration as is, because we are still going to use the LED that is connected on PA5. So that is the blinking LED here. So that is why I haven't removed this code here. Okay, so we are still just enabling the clock for GPIO-A, all right, and we are configuring the LED as an output, and we've got a no pull, so everything is going to remain as is for that configuration. Right now we can then create another function, and the function now we're going to create is the one that we're now going to write the parameters, as I said, for our serial port. So these are now the high level parameters, the same one you see on your device manager serial port settings. And before we can write this USART2 parameters function, please guys, just take a moment and give this tutorial a thumbs up if you find anything useful, and also subscribe to CMTEQ channel. That will be much appreciated. Thank you so very much. Okay, so what we're going to do here is we're going to write a void function. So that's a function that returns nothing. It's basically just writing parameters, right? So I'm going to just put a comment here, and I'm going to just say USART configuration. And here I'm going to have my void and call it any name you want. So I'm going to say USART2 config, like that. Right, void, no parameter inside. So now inside this function here, we need a specific parameter instance. So that is going to be the same one as this GPIO init dev, but for the USART. And to get that parameter, we need to come into the STM32 HAL UART.h file and find the type handle for this structure here. I think it's somewhere right here at the bottom. So we're just going to copy it, right? We're just going to copy it and come and paste it. I'm going to paste it here on the define, and then I'm going to give it a name. So the name that I'm going to give is the name that I'm going to use to access all my setting, my high level setting for my USART initialization or my USART parameters. So here I'm just going to say USART2, just like that. So which means by using this variable here, USART2, we will be accessing all the structures parameter that are defined into this handle here. So now we can come back, and I'm going to say USART2, and as soon as I hit the dot there, now we've got the world of parameters available to us. So the first parameter here, we're looking for the USART that we're going to use. So that's the instance that we have to specify. So we have to go instance, and you can see what it is expecting. So that is instance, and then we're going to say it is equal to USART2. So we're using the USART2. Then we come again, USART2 dot. Now the next parameter here is we need to initialize the baud rate. So we're going to take the init, all right? We're going to take the init, and then we're going to access the baud rate in the parameter initialization. So in there, then we can pass the baud rate. Now here you can give any baud rate you want. So if you say 9600, that is the standard baud rate. But if you want it to go very fast, then you have to increase the baud rate. So you can go like 115 200 as a baud rate. Now we go to the next parameter. Now the next parameter into our initialization init dot is going to be the flow control. Now all these parameters, they are available here into the same header file, so you just have to look for them. So we're looking for the hardware flow control, and we're gonna say none. So we're gonna just copy this and then just paste it here. So now we go to the next one. So USART2.init. The next one here is the stop bit. Okay, so that is also a 32-bit integer, and that is going to be equal to, so we also need to find the USART stop bit. So stop bit, as we've seen in the device manager, is usually 1. So we're just going to copy the stop bit 1 and paste it here. Right, now we go to the next one. So USART2 dot, now the next parameter, USART2 dot init dot, we're gonna now take the mode, right? And the mode here is to specify whether we want to use it for transmit, receive, or in which mode. So we're going to go back into that file and find the UART mode, TX and RX. So we're going to select for TX and RX since we are using both PA3 and PA2. So I'm just gonna copy that and paste it here. Right, now we got 2 more parameters to go. So that's going to be USART2.init dot, now what's the next parameter here? The parity bit, right? So we need to specify the parity bit, and the parity bit, as we've seen onto the setting of the serial port here, if we may just access it again, we can see that the parity bit here is set to none, right? So we can also just choose the parity bit and set it to none. So where is the parity bit? Right here. So I'm just going to copy it and set the parity bit to none. Now we go to the last parameter, USART2.init dot word length. So the word length, as the name implies, is the size of the word in which you want to transmit, whether it's gonna be 8-bit or 7-bit. Now the word length parameter is not available into this main header file. We have to go into the smaller header file here, that is the UART underscore external, and in here, just if you scroll, you're going to find your way, and you're gonna see you got the UART word length for 7-bit, 8-bit, and 9-bit. So we're going to take for 8-bit, which is a standard. Okay, so we're going to then take it and paste it here, right, semicolon. So the next thing here is basically just to pass all these parameters into the initialization function that is now going to write all these settings. So you guessed it, that function is going to be the similar one, but not a GPIO one. It's going to be the UART function. So we're gonna say HAL underscore UART underscore init, right? And inside this function, we're gonna pass the pointer parameters, right, to reference the same variable as the GPIO init here, but for this guy here, the UART handle type def. So we're gonna copy that, and I'm going to paste it in here and pass the n% to reference all my parameters. Now, as is, we basically done with our serial configuration. Now, because it is a serial port we are configuring, the port might not be available. There might be an error while writing all these settings in. So we have to handle that error if it happens. This is why this initialization of the serial port, the HAL UART, if we may go in that function here, you can see it's a status function. So it returns a status of your serial communication port because you're trying to open it. Now, if the status is not okay, it's going to give you an error. You can even see a return type here, HAL error. Okay, so let's click on here, HAL status define, and see what are the type of error it can give you. So these are the type of return you can get, right? You can get HAL OK, HAL error, busy, or timeout if it's not accessing the serial port. So in order for us to now get this return and handle it, we have to put that function into an if condition, right? So I'm going to then open an if statement here. I'm going to say if this function here, the initialization function where I'm passing this USART2 reference to all of these parameters, if this function does not return a HAL OK like that, as we've seen here, if it does not give HAL underscore OK, that means there is an error, right? So what I'm gonna do is I'm then going to handle that error inside my if statement here, right? And how you going to handle this error? And you have to create a function here that is going to handle the error. We're getting an error here already. Something, okay, there is a problem here. The equal sign must be close to that exclamation mark, because we are saying if this return here is not equal to OK, right? Then we need to handle the error. So I'm going to create a function. I'm going to call this error handler. So that's the name of the function, error handler. Now this function haven't been defined yet, so I have to come and try to define this function. So I'm gonna say void error handler, and I need to write the settings for this function. So what do I want to do here? I want to just flash this LED if there is an error. Flash it very fast. So in order for me to do that, so I'm going to call the GPIO toggle pin function. So I'm going to say HAL underscore GPIO toggle pin, and I'm going to pass the parameters, so which is PA5, so that is GPIO A and GPIO pin underscore 5. So I want to toggle that pin 5, right? And I want to delay. Now we don't have a delay function here, but because we already initialized the HAL init here, and it is generating a 1 millisecond interrupt after the system tick have been initialized, now we can just call the HAL delay function, which is HAL underscore delay, and we're going to pass 1000. So that's going to be 1000 milliseconds. So that basically means 1 second delay. So this means if there is an issue with our serial port configuration, we're gonna get into the error handler, and that's going to flash the LEDs. All right, now we can go into our main function here and start writing the code that's now going to transmit the data, since the serial port have now been configured. But before we can do that, please don't forget to copy this function here. Okay, you have to write it there so that you can enter the configuration, because if you do not do that, then you are not going to get a serial port work, because you actually not writing the settings. So never make that mistake. Once you write a function, pass it in there. And the other thing is, don't forget the function prototype. So I'm going to copy it and come into my main header file here, and I'm going to pass the function prototype here, and I need another one for the error handler, and I'm going to also pass that one, so that we have our function prototype, so that the C compiler can be happy. All right, let's stop this tutorial here before it gets too long. Please stay tuned for part 2, where we're going to just complete the code into the main function here to do the transmission of our data via the virtual serial port into the computer. All right, until next time, thanks for watching. Once again, please give it a thumbs up and subscribe to CMTEQ channel. Cheers.